I wanted to do an example here in regression. So you recently completed 9.1 on correlation, and the main point for correlation would usually be to get what is called a regression line. So correlation was measuring how well the data fit to a line, and now we want to actually find that line. So we need to find the slope and y-intercept of that line. There are many ways to do that in Excel and something like Google Sheets. One of the quickest would be just to directly use formulas. So the formula to find the slope is called slope, and you give it the x and y values. From the previous section, when you gave correlation, it didn't matter which value was the x and the y value. And if you had swapped them, you get the same thing. They are still correlated in the same way. But this one we do have to be careful to give the right y and x values, otherwise we would get a different slope. So it does want the y values first, and then the x values. So our slope here is 0.04. One way to think about what the slope means is for every increase in 1 for your x values, the y values go up 0.04. So this problem is about the height of buildings compared to the stories. So every foot in height increases the amount of stories by 0.04 stories. And we could maybe change that ratio a little bit to make that make more sense. But that is the idea and how to interpret the slope. If this were negative, then the amount of stories would just go down. The y-intercept is a somewhat similar named formula called intercept. So this is all for linear regression. So you give it the y values and then the x values. So our y-intercept is 20. So that would mean if our x value is 0, y would be 20. And so here, and oftentimes, the y-intercept doesn't have too much practical purpose. The x value of 0 would mean that the height would be 0. So there are no buildings with a height of 0, then they would have 0 stories. So that doesn't quite work out here. Also, the x value of 0 is way outside the range of our x values. So only if it's inside the range of our x values can we attempt to use it. Otherwise, we have to be very careful about how we would think about what this might mean. All right, so our regression equation is going to be y equals that slope. This will want 3 and then 2 decimal places, so 0.041 times x plus the y-intercept. This wants 2 decimal places, so that'll be exactly 20. So this is the equation that relates these variables here. 0.041 times x, so the slope, and the y-intercept will be 20. So if we were doing this on our own, and this were brand new data to us, we would also have to verify that these are correlated enough to find this. We can always find the regression equation, but we need to make sure that they were correlated enough. So the correlation R would need to be large enough to verify that this was correct. And we can use the table that we had before for our cutoff values, or we can find the t-test statistic to compare. So 0.88, we would have to go back. This problem doesn't have the tables with us because they say to assume that they already have a significant correlation. So this is just the regression step. But if we were doing this on our own, we should first verify that they are correlated enough, and then if they are correlated enough, we can find the regression equation. As before, it might be easier to just graph this in Excel to see what these look like. We are predicting the amount of stories from the height, so height should be the x-axis, and stories should be the y-axis. This has a positive slope and a positive correlation. These will always have the same sign, so they'll both be positive or both be negative. So the answer is either C or D. And they also look quite similar initially, so maybe we should find the graph ourselves and see if we can compare. So we can insert. Usually the recommended chart makes a good guess. It's connecting with the line, but it's not quite the line we want. So let's try our direct scatter plots. We can actually insert the regression line directly on our table or our graph here. So if we go to Add Chart Element, Trend Line, I'm actually going to go to More Options first. So I want linear, and you can see it's already there now. And I can also choose to display the equation on the chart. So this is another way I could have quickly gotten the regression equation. The last way to get your regression equation, we could have also used the data analysis toolpack. So Excel, you can see, only finds the trend line between the x values, the range of your x values. So that's actually a little more appropriate than the homework has done here. All right, so we want to compare these answers now. So they do look quite similar. Our x and y axis are the right labels and the right sets of values. And I think the quickest way to compare them is actually going to be to look at the line itself. So a regression line should fit between the data. So it should make sense of where it goes. And that is the most clear answer here. So the regression line is above almost all of the data. And there is no way that that would happen. The exact placement of the line is determined when we go through the correlation and calculate everything else. So it's not, we can't 100% figure that out just by looking at it. But this is definitely not what it would have outputted. And the reason being, if these stories, so this looks like it's increasing by 10, this has a y-intercept of 30, this graph would have a y-intercept of 20. They do look to have about the same slope. Both of these lines look to be about the same steepness. So we're going to want to choose the one here. But even visually, before comparing detailed levels as we did there, we could have said that this line looks like it's passing through the data pretty well. This line is not passing through the data at all. It is above all of the data. So this would not be an appropriate regression line. All right, and then next we're actually going to use the regression equation. The main reason why we find this, it is nice to find the numbers and graph it so we can see the pattern. But the biggest reason why we might do this is to predict new values. So now that I have this, I can predict any x value that is reasonable, so something within my range or very, very close to my range, and predict the number of stories. So I'm going to give it a height and predict the number of stories. So predict the value for a height. This is the x value of 503. We're going to have to do this 3 or 4 times. So this might be nice to have this work a little quicker. So I'm going to give it an x value, and I'll leave this spot blank for the x value, and then I'll calculate the y value. We'll go ahead and input the first one for right now. So we're going to apply the line. So the line is the slope times your x value plus your y-intercept. So if your y-intercept is negative, which is fine, and if your slope was negative, that's fine. That'll take care of all of it, but the standard form of a line is mx plus b. So if my building had a height of 503 feet, I'd expect it to have 40.84757. Right, and this doesn't quite make sense. Stories is a whole number. And we can actually see that the homework is, the answer choices here are rounded all the way to a whole number. We have to be careful though, there are still two possible answers. So 40.8 rounds to 41, but the answer still might be not meaningful. There are two reasons that this could be not meaningful, but we've already checked the first one, or they have already told us the answer. There is a significant correlation here, so this is appropriate to find the regression equation. But the only thing we have to verify then is this an x value that I should be predicting? And graphically may be a nice way to do this here. So we can see our x values go from a little less than 500 to a little less than 800. And we can see that our smallest x value is 477, and our largest x value is 774. So I should not predict outside that range. If I were to predict maybe a 780, that might be acceptable. We'd have to be careful. But something like 900 is definitely outside the range. So this is inside the range. 503 feet is with our range of x values from about 470 to 770. Okay, so since I made this calculate from the cell, now I can just update my new number. So 649, let's do the quick check first. Is this a value I should be predicting? Yeah, 650 is in my range. And we can see visually it's going to be about right here. So if I predict for 650, I'm going to get a number of stories above 45, maybe 46 or 47. So we can see that it's going to end up being this 47. Let's go ahead and input and calculate it. So 649 times the slope plus the y-intercept calculates to 46.89, so 47. And this is meaningful. This is a value that I should be predicting, or could be. All right, let's do the quick check again. Should I predict a value for 310? So 310 would be way over here. This is very far outside of the range of our values, and we don't know if this pattern continues for buildings that are that small. So that is not meaningful. Okay, lastly, 726, that is just under our value of 770, so we can predict there. So 720 is going to have a number of stories very close to 50. We can see that here. And with our answer choices, there's only one possibility there. But let's go ahead and calculate it. So we can see it's nearly exactly 50. Right, so to predict, you substitute into the regression equation, but just make sure to check that that's a valid range, or that that value is in your range.